Hi, I'm Pelin from Chemistry Department and this is my Physics 102 project. Objective: to demonstrate the Biot-Savart law by calculating the magnetic field at various points in a Helmholtz coil setup based on relevant variables and to compare these theoretical values with those obtained through measurements. Theory: the equation used to calculate the magnetic field produced by a current is known as the Biot-Savart law. This law enables us to calculate the magnitude and direction of the magnetic field produced by a current in a wire. The Biot-Savart law states that at any point P, the magnetic field dB due to an element dial of a current-carrying wire is given by, where micro is the permeability of free space, I is the current, and r is the distance. Reorganizing this equation for the case of magnetic field at a point P along the axis of a current-carrying loop of wire we have: in a Helmholtz coil, there are two parallel looped wires with radius r situated at a distance r from each other. If the currents passing through them are also parallel, their combined magnetic field at the middle point of the central axis can be shown as, where n is the number of loops each coil has. With y equals 0, the equation reduces to, thus, magnitude of magnetic field at the middle point of two identical concentric coils with a distance r between them is proportional to permeability of free space, number of loops on each coil, and the current passing through them. It is also inversely proportional to the shared radius. Equipments: DC power supply, ruler, Gauss meter, Helmholtz coil apparatus, and connector cables. Procedure: the radius of the coils will be measured and will be placed at a distance r parallel to each other on a common central axis. Their number of loops n will be noted. The coils will then be connected to the power supply and the current passing through these circuits will be set to a predetermined value. A ruler will be put through their common axis to determine the exact middle point. After taking a note of the distance between the center of each coil and the middle point, magnetic field of this point can be calculated by plugging in the n, I, and r values into the given equation. This value can be compared with the experimental data obtained by directly measuring the magnetic field with a Gauss meter. The process will be repeated a couple more times by changing the voltage on the supplier and the resulting current through the wires. In our case, the coiled wires can carry 2 amperes at most, so the current will be amplified starting from 0.05 amperes all the way up to 0.19 amperes slowly. The n and r values remain constant. Experimental results will be tabulated along with the theoretical values, and error percentage for each case will be calculated. Conclusion: as expected from the theory, magnetic field at the specified point increased linearly with the increase in current.